Good morning, students. Today we are going to learn about powers of I. I power se gi maramda ngasi tamasi ko. We know that I is the imaginary number and I is equal to root over minus 1 and I square. I square is minus 1 whole square. It will be equal to minus 1. Then I cube. I cube se leram taragadi magi power se kamine reduce tawni haradi exponent lo use tawrani. But this I cube can be expressed as I square into I, and since value of I square is equal to minus 1, minus 1 into I is equal to minus I. So this I cube is reduced to minus I to the power 4. I to the power 4 is the multiple of 2, and so this I to the power 4 can be expressed as I square and whole square, and value of I square is minus 1 and minus 1 whole square is equal to plus 1. So main taraga I की value से minus 1 tare. I square की value से minus 1. I की value na root over minus 1. I square की value na minus 1. I cube की value से minus I tare ko. And I to the power 4 is equal to plus 1. Then I to the power 5. I to the power 5 से कमाने थम्बे यारे. I to the power 4 into I to the power 1. Since I to the power 4 is equal to क्या माने 1 ताई को 1 into I is equal to I. So I to the power 5 is reduced to I. Then I to the power 6. I to the power 6 से 2 की multiple ने बको 2 की multiple over the express तव से I square whole to the power 3 and value of I square से minus 1 ने को minus 1 whole to the power 3 and keep over मागी power से odd over नि ना minus 1 पंगे I to the power 7. I to the power 7 से odd number ने I to the power 6 ने even number ने even number होता है 2 की multiple the express तव से if the powers of I is not an even number, then it is odd number. Even number or the tardima odd number or a this odd number is expressed as 7. 7 is 6 plus 1 ni ko. The 7 dagi hantaba number amaga 1 namaga plus tawraga express tawrasi. Then I to the power 6. 6 is the multiple of 2, and so it can be expressed as I square whole to the power 3 into I. Since value of I square is minus 1 whole square into I. Plus tare ko plus 1 into I is equal to plus I. Sigi mawong the I to the power 7 ja I the reduce tawrani ba. Value asoba I की powers pyramid khaleba. First I to the power 20 is 24. Since 24 is the multiple of 2, it can be expressed as I square whole to the power 12. 2 into 12 is equal to 24, and then replace the value of I square by minus 1. Minus 1 whole to the power 12 is equal to plus 1. Then in case of I to the power 27, since 27 is not an even number, it is odd number, so this 27 is expressed as 26 plus 1, even number plus 1. By exponent law, it can be expressed as I to the power 26 into I to the power 1. Since this 26 is the multiple of 2, and so express this 26 as the multiple of 2. I square whole to the power 13 into I square is minus 1 tareko, minus 1 power 13 into I. Minus 1 power 13 even number and value of I can multiply tawnaradi minus I tareba. Dun every powers of I sa kaida reduce tawba yani hay taragadi every power of I can be reduced to plus 1 minus 1 plus I and the minus I. Sumaita reduce tawni aduga nga reduce tawbagi form sa even number oiragana 2 gi multiple de iro, odd number lairagana even number oigadaba kwa even number plus 1 nangi even number sa given number dagi 1 less oigadaba. Next, negative powers of I. Nangi I gi powers and negative oiba kwa I to the power minus 1. I to the power minus 1 minus means inverse ne. It can be expressed as 1 by I. Nangi I gi power se odd number oitar di even lang na ba multiply tawni ba. We should multiply denominator and numerator by another I. I divided by I into I divided by I square, and I divided by minus 1, which is equal to minus I. So I to the power minus 1 is equal to minus I tareko. Then in case of I to the power minus 2, 1 divided by I square equals to 1 divided by value of I square is equal to minus 1. 1 divided by minus 1 is since value of I square is equal to minus 1, so 1 divided by minus 1 is equal to minus 1. I to the power minus 2 have a second manare minus 1 manare ko. Then I to the power minus 3. It can be expressed as 1 by I to the power 3. Since 3 is the odd number, so we should divide denominator and numerator by another I. 1 divided by I to the power 3. It can be expressed as I divided by I to the power 4. I dum lasereko. Then this 4 can be expressed as I square and whole square, and replace this I square by I square gi mahuta kaina sentare minus 1 whole square. I divided by minus 1 whole square is equal to plus 1, so I divided by 1 is equal to I. Then what about I to the power minus 12? Since 12 is the even number, it can be expressed as 1 divided by I to the power 12, and 1 divided by this 12 can be expressed as I square whole to the power 6, and replace this I square by minus 1. Minus 1 whole to the power 6 is equal to plus 1, so 1 divided by 1 is equal to plus 1. Even number oiragadi multiple of 2 da thamba yareko. Odd number oiragadi I to the power minus 13. 1 by R to the power 10. Sigi 13 se odd number oireba. Even number oiraknabagi damakta koina denominator numerator da I amana multiply taunebako. We should divide denominator and numerator by another I. We have I divided by I to the power 14. I divided by this I square 14 se I square whole to the power 7 na thamba yare, and replace the value of I square by minus 1. I divided by minus 1 to the power 7 se minus 1 oina taniba. Duna I da minus 1 na divide tau taragadi minus I orane. Duna positive powers of I so plus 1 minus 1 plus I minus I da reduce tauba yai, aduga negative powers of I so plus 1 minus 1 plus I minus I da reduce tauba yani ko. Kay sizinaraga koina I square minus 1 natraga I to the power 4 is equal to 1 haiba rule ani se sizinaraga. Nangna I gi square da warasu yare, I gi power 4 da warasu yare ko. Next topic. The square root of a negative real numbers. Koina hana tamisina positive khatangi tambaka hasingna negative ki. Since value of I square is equal to minus 1 and also minus I whole square. Minus I whole square can be expressed as minus 1 whole square into I square, which is equal to minus 1. Minus 1 taane maramdi kaigino minus 1 whole square se plus taeba ko. Tuna I square ki value so minus 1 tare, minus I whole square ki value so kya tare minus 1. Therefore, the square root of the minus 1 will be plus minus I. Plus I or minus I. Anisida oiningba mo obiya. Plus I oirasu yare, minus I oirasu yare ko. Similarly, root over 3I whole square is equal to root over 3 whole square I square. Root over 3 whole square is equal to 3, and value of I square is equal to minus 1, and product of 3 into minus 1 is equal to minus 3, and minus root over 3I whole square is minus 3 minus root over 3 whole square into I square, which is equal to minus 3. Root 3I ki whole square so minus 3 tare, minus root over 3I ki whole square so minus 3 tare ko. Therefore, the square root of minus root over 3 is plus root over 3I and minus I root over 3. Ani thokna leiraneba. Negative minus 3 habise negative real number amani. Negative real number amagi square root che ani laineba, plus root over 3I haiba mane minus root over 3I haiba mane. Sumain tauraga kuina any real number amagi square root che ani ni lairani ko. Next topic is identities defined in complex numbers. Complex number the defined riba identities singsiniko. For any two complex numbers z1 and z2, number 1, z1 z2 whole square means a plus b whole square habaniko. A gi mahuta z1, b gi mahuta z2. So z1 plus z2 whole square is equal to z1 square plus 2 times of z1 z2 plus z2 whole square. Roman number 2, z1 minus z2 whole square is equal to z1 square minus 2 times of z1 z2 plus z2 whole square. Z1 square minus z2 whole square is factorized into z1 plus z2 and z1 minus z2. Number 4, z1 plus z2 whole cube means a plus b whole cube se koina complex number z1 z2 na sintaragadi identity se dum whole tawra leibako. Z1 plus z2 whole cube is equal to z1 cube plus 3 times of z1 z2 square plus 3 times of z1 square z2 plus z2 and whole cube. Sigi moong da koina expand tawni in case of negative expression dadi z1 minus z2 whole cube is equal to z1 whole cube minus 3 times of z1 square, z2 plus 3 times of z1 and z2 whole square and minus 2 z cube sumai taraga plus already plus oin phangani minus oi tardi plus minus ain lakani china complex number the define to identities ni ko. Next topic, the modulus and the conjugate of a complex number amagi modulus and conjugate ni ko. Let z is equal to a plus ib be a complex number, then the modulus of the complex number z denoted by modulus enclosed z enclosed within this modulus sign is denoted by modulus of z is equal to root over a square plus b square. Root over a square plus b square means this a is the real part of the complex number z and this b is the imaginary part of the complex number z. Koina mamangi class the real part na kaino imaginary part na kaino phazan tongre ko. Example, there is a complex number z is equal to 3 plus 4i. Here real part is equal to 3. Real part haibadi I galeminadava. The number not involving with this imaginary number I is called real part, and the number involving with this imaginary number I is called imaginary part. And so here value of a is equal to 3 and the value of b is equal to 4. The complex number z sigi modulus hai. Modulus of this complex number z is equal to root over 3 square plus 4 square. And since 3 square is equal to 9, 4 square is equal to 16, their sum is equal to 25, and square root of 25 is plus minus 5, but we should take the positive value of the square root. Nangi positive value launeba square root to gi kaigino haitaradi modulus habise positive quantity neba ko aduna plus 5 on irani. Modulus haitaradi kamaina define tawre root over a square plus b square, where a is the real part and b is the imaginary part of the complex number z. Modulus ki value di always positive thagadamne ko. Next, let's define conjugate of a complex number. Let z a plus ib be a complex number, then the conjugate of z is denoted by z bar. Conjugate hai tardi z ki mathakta bar am tapkani and is defined as z bar is equal to a minus ib. A plus ib conjugate is equal to a minus ib means there is change in the sign of imaginary part. Imaginary part says the sign change tawgani, plus layer magadi minus lakani, minus layer magadi kai lakani, plus lakani ko. Example, complex number z1 is 2 plus 3i. So the conjugate of z1 denoted by z1 bar, it will be equal to 2 minus 3i. Imaginary part se plus ne, conjugate already minus the change tawgani. In case of z2, complex number is minus 1 minus I. z2 bar will be equal to minus 1 minus I minus layer banina kaida sense tawgrani plus the sense tawgrani bako. Conjugate lobase kaida sign change tawni haiba nangi imaginary part to adu the sign change tawgani, plus layer magana minus the minus layer magana plus the. Next topic, some results defined on moduli and conjugates of a complex number. Moduli mean moduli have say modulus ki plural form niko. Some results defined on moduli and conjugates of a complex number. Complex numbers have the defined over modulus ka conjugate ka properties ngatani. For any two complex number z1 and z2 we have number 1. Modulus of product of z1 and z2 is same as the product of modulus of z1 and modulus of z2. z1 z2 the product lower modulus lower the modulus of z1 modulus of z2 ki product kamane. Roman number 2, z1 divided by z2 modulus is equal to modulus of z1 divided by modulus of z2, but modulus of z2 cannot be equal to 0. z1 the z2 na divide over gi modulus hai. z1 gi modulus ta z2 gi modulus na divide tawbaga mane, aduga modulus of z2 di kai tabe ade 0 tabe ade ko. Number 3, z1 into z2 conjugate, it will be equal to z1 conjugate into z2 conjugate. Roman number 4, z1 plus minus z2 conjugate will be equal to z1 conjugate plus minus z2 conjugate. z1 plus z2 conjugate sida hana nangi complex number ani se sum taraga conjugate lobaga sum of conjugate of z1 and conjugate of z2 siga manani plus ramagana plus c tare minus ramagana minus c tare ko. For Roman number 5, z1 divided by z2 conjugate. Whole conjugate will be equal to z1 conjugate divided by z2 conjugate, but this z2 conjugate cannot be equal to 0. So z2 ki conjugate cha 0 tabadi yade ko. So akoina rule khara tame identity khara su khange ko, then powers of I se kamaina reduce tawni have se khange. Now let's come to exercise 5.1. Here exercise 5.1 is express each of the complex number given in the exercise from question number 1 to 10 in the form of a plus ib. Exercise 5.1 the question 1 dagina 10 about the hour of expression mayam se a plus ib the express to have a plus ib means in the form of complex number. Complex number danang express to duini ko. Here question number 1 is 5i into minus 3 by 5i. Product of two complex number ni ko. First find the product of real numbers and imaginary numbers. Real ka into holo. Imaginary ka ko. 5 into minus 3 by 5 and this I is equal to I square. Cancelling plus 5 and minus 5 we have minus 3 and value of I square is equal to minus 1. Koina I square ki value di minus 1 is adina minus 3 into minus 1 is equal to 3 tare, but we have to express this 3 in the form of a plus ib. This 3 is the real part and imaginary part the tardi. It can be expressed as 3 plus I into 0. So next Roman number 2, I to the power 9 plus I to the power 19. First reduce this power 9 and power 19. This power 9 can be expressed as I to the power 8 into I to the power 1 plus this power 19 can be expressed as I to the power 18 into I to the power 1. 8 can be expressed as 2 into 4 and this 18 can be expressed as 2 into 9. Then replace this I square by minus 1. Minus 1 whole to the power 4 into I plus minus 1 whole to the power 9 into I. Minus 1 whole to the power 4 is plus I to the power 9. Minus 1 to the power 9 is minus 1 I. Minus I is equal to 0. 0 tare ko, but we have to express this 0 in the form of a plus ib since 0 plus I into 0. Real part is 0 and imaginary part is 0. Real part is 0 tare, imaginary part is 0 tare ko. Next question, question number 3. I to the power minus 39. I to the power minus 39, it can be expressed as 1 by I to the power 39. Then multiply denominator and numerator by I. I divided by I to the power 40. Since this 40 can be expressed as 2 into 20. I divided by I square minus 1 to the power 20. Minus 1 to the power 20 is a plus tareko. I divided by plus 1 is equal to I. Then express this I in the form of a plus ib. So imaginary part yaureba nangi real part yaudreko and real part is equal to 0 hapsil. Next question, question number 4. Express this expression in the form of a plus ib. First term and second term kya yaure ani yaure ko. First multiply 7 plus I7 by 3. 3 7 21 3 7 21 I. Then 7 plus I7 multiplied by I. It will be equal to 7I plus 7I into I is equal to I square. 21 plus 7 is 28I and 7 value of I square is equal to minus 1. 21 minus 7 plus 28I. 14 plus 28I tare ko. Aduna nangi expression che A plus IB the thambere. Next question is question number 7. Here question number 7 is the period expression che A plus IB the reduced tawduini ko. Kanagi sum putokani. Here we have to find the sum of this complex number and this complex number. Complex number ani kamaina nahan addition kamaina plus se sum putoki ay taragadi. Find the sum of real part and find the sum of imaginary part. Have a rule lagi ko. To the anisigi real part che 1 by 3 ne. 4 is the real part of the second complex number. 7 by 3 is the imaginary part of the first complex number and 1 by 3 is the real part of the second complex number. So we need to find 1 by 3 plus 4 and I 7 by 3 plus 1 by 3. And the real ga plus tore, imaginary ga plus tore ko. 1 by 3 plus 4, LCM laure 3 tare, 3, 4 is equal to 12. 12 plus 1 is 13. LCM, same denominator. Find the sum of numerator, 8 by 3 minus. Then write minus 4 by 3 plus I. This expression is in the form of a plus ib, and this expression is also in the form of a plus ib, and there is a negative sign in between first complex number and second complex number. Then apply the difference of two complex number. 13 by 3 minus 4 by 3 minus, it should be plus. Then write I. Write imaginary part of first complex number 8 by 3, and imaginary part of second complex number is plus 1. Find the sum of these two expressions. Same denominator, 13 plus 4 is equal to 17. LCM 3, 8 by 3 से LCM 3 निकाल 3 से 1 का multiply तो उतार दे 3, and 8 minus 3, it will be equal to 5. And so this expression is reduced to 17 by 3 plus I into 5 by 3, which is of the form a plus ib. Next question is question number 8. 1 minus I whole to the power 4. Express 1 minus I whole to the power 4 in the form of a plus ib. This power 4 can be expressed as 1 minus I whole square and whole square. Then expand 1 minus I whole square by using the formula a minus b whole square. A minus b whole square have a rule do apply to reduce the 1 square minus 2i plus I square. This 1 square is 1, 2i, and value of I square is equal to minus 1. Cancelling this plus 1 and minus 1, we have minus 2i whole square. Minus 2 whole square is equal to 4, and write I square. Since value of I square is equal to minus 1, and 4 into minus 1 is equal to minus 1, minus 4 nikwa, we have to write this expression in the form of a plus ib. So, 8 I into 0. I into 0 is equal to 8 tausileba. Maramdi kaigino, here real part is minus 4 and imaginary part is equal to 0. Real part na minus 4 dazare, imaginary part na 0. Next question, question number 9. The given expression is 1 by 3 plus 3i whole to the power 3. Si expression se pireba. Si kaigi form da koina thamni hai taragadi a plus ib da thamdoini ko. A plus b whole cube ki formula expand tarase. Sina a, sina kai tare, b tare ko. 1 by 3 whole cube plus 3. Write a square. 1 by 3 whole square, write b. 3i plus 3, write a. 1 by 3, then write b square. B is 3i whole square plus write b cube. B cube is 3i whole cube. A cube plus 3 times of a square b plus 3a b square plus b cube. Formula irekwa. Since 1 by 3 whole cube is equal to 1 by 27, 3 into 1 by 3 whole square is 1 by 9, and 3 into I plus 3 into 1 by 3. Cancelling 3 cancel the greco. 3i whole square is 9 into I square, and 3 cube is 27 and I cube. 1 by 27 plus 3 into 3 is 9. Cancelling 9, we have value of, we have I katang lemeko 9. I square is equal to minus 1, then 27. I square into I. 1 by 27 I, 9 into minus 1 is equal to minus 9. 27, value of I square is equal to minus 1. And then write this I. Then separate real part and imaginary part. Here real part is 1 by 27 and this 9. And imaginary part is this I and 27I. Sitameko. LCM of 1 by 27 and 9 by 1 is equal to LCM se 27 go 1 gatare. 27, 1 minus their product is 243 plus 1 minus 27 is minus 26. Difference is minus 242 divided by 27 plus minus 26i, which is equal to minus 242 divided by 27 minus 26i. Sige sina kaino. 1 by 3 plus 3i whole cube sigi a plus ib the express tauba natra reduce tauba expression amani ko. Your next question is question number 11, 12 and 13. Find the multiplicative inverse of each of the complex number. Multiplicative inverse puthokpa ko. Question number 12 ka, question number 13 ka. Question number 12. Let z represent the given complex number root over 5 plus 3i. The multiplicative inverse of z is given by 1 by z. Since z into 1 by z is equal to 1. Z chiga 1 by z chiga into double se 1 tani baduna 1 by z se kai kore 1 by z is called the multiplicative inverse of the complex number z. 1 by z, write the value of z root over 5 plus 3i. Since the expression is plus, we should multiply denominator and numerator by its negative part. Plus or magadi negative na multiply togani, negative or magadi plus na multiply togani ko. Root over 3 minus 3i divided by root over 3 plus 3i into root over 5 minus 3i. Root over 5 by 3i divided by root 5 whole square. A plus b into a minus b tareko, which is equal to a square minus b square thame. 1 by z is equal to root 5 minus 3i. Root over 5 whole square is 5. 3 square is equal to 9. I square is equal to kaiga manare minus 1. Minus minus plus, and 9 plus 5 is equal to 14. Then divide this term and this term by 14. Root over 5 by 14 minus 3i by 14, which is of the form a plus ib. A plus ib the thumb ko. Question number 13. Complex number z is equal to minus I. The multiplicative inverse of this complex number z is given by 1 by z, which is equal to 1 divided by minus I. Then we should multiply denominator and numerator by another I divided by minus I into I. Value I into I is equal to I square tareko, and I divided by value of I square is equal to minus 1 minus minus plus I phangi. Baduna nangi minus I habisigi multiplicative inverse I orani. I into minus I is equal to 1 taduini ko. Next question, question number 14. Express the following expression in the form of a plus ib. Question number 14 the nangon the period expression ja a plus ib the thangada. Question number 14. Here the given expression is 3 plus I root over 5 into 3 minus I root over 5 divided by root over 3 plus root over 2I minus root over 3 minus I root 2. Expression of numerator is in the form of a plus b into a minus b, and it can be expressed as a square minus b square. So this expression is equal to 3 square minus I root over 5 whole square. But in case of denominator, first open this first term and second term sigi brackets and open to siko root 3 plus root 2I and minus root 3 minus minus plus root over 2I. 3 square is 9. Root over 5 whole square is equal to 5, and value of I square is equal to minus 1. Minus minus plus tareko. Cancelling plus root over 3 and minus root over 3. Root 2I plus root 2I is equal to 2 times of root 2I. And 9 plus 5 is equal to 14. 14 divided by 2 root 2I. And this 14 divided by 2 we get 7, and remaining factor is 7 divided by root 2I. Silem horrible. Then first rationalize this imaginary number I. See and rationalize toxico 7 divided by root 2 into I na multiply to sele I divided by I square. 7 I divided by root 2 into minus 1. Value of I square is minus 1. 7I. Then rationalize this irrational number root 2. So we should divide denominator and numerator by root 2. 7I into root 2 divided by root 2 whole square into minus 1. Minus 7. Siki minus se khona numerator thamse ko minus root 7 root 2I divided by 2. Siki se imaginary part ne real part yaw bra real part yaw the ko aduna mamang the 0 ama hape. 0 minus 7 root 2 divided by 2i. ꯑꯗꯨꯗꯤ ꯃꯥꯁꯦ ꯀꯩꯒꯤ ꯐꯣꯔꯝꯗ ꯂꯩꯔꯦ? Which is in the form of a plus ib. Here real part is equal to 0 and imaginary part is minus 7 root 2 divided by 2. Sina real part ni, sina imaginary part. For today, let's end here.